Alright, so I've gone ahead and set up a demo application which models a hotel reservation system. In this video we'll be implementing paging because as it stands these page buttons don't do anything. We're currently on page 0, so basically when I scroll through these buttons I want, if I press next I want to advance to the next page. When I go back to the previous page. So that's what we'll be having a look at. And to jump right into the code, this just shows the hotel controller. So we're using the hotel repository to get all the hotels, and this is chucked into a page object. This page object is stored directly in the model, so the Thymeleaf template can refer to the hotels through the results variable. And the template itself, we just need to be concerned about this table footer section because that is what corresponds to these page links down the bottom here. So to get things started, I just want to motivate some of the reasons why I created this module and the headaches faced if you try to implement this yourself. So to start with, if you wanted to, this is the next button. When you press next, if you wanted to increment the page, how would you go about doing that? So, the first thing that might come to your head is you create a variable that stores the page value, and you can extract this from the query string through the request object. So this page value will store the current page of 0, and then from here you'd have to perform additional logic, like you'd have to cast the page to an integer in order to increment it. Then you'd have to deal with the fact that what happens if that page value isn't numerical. You could get errors for whatever reason. Additionally, what happens if the page is missing? What do you do then? What happens if the page is currently on the last page? Should you be able to continue incrementing it? Likewise for decrementing. If you're on page 0, you shouldn't be able to go below 0. All of this sort of stuff gets really complex, and it's way too much code to have to write in the template itself. Additionally, there's other issues because we've only got one key value pair in the query string at the moment, but let's say that we were searching for hotels at a specific location. So a query string is a lot more involved. It's got the location information and the sorting details, but when we page, we don't want to lose all this location and sorting information. All we want to do is simply modify the current page number. So this is what my module I created does. All it does is it will look for the key that needs modifying, it will update that only, and it will keep everything exactly the same, including exactly the same order as well. So the only thing that will be updated is the page number, and everything will remain the same. This basically eliminates all of this tedious code that you have to write in the template, and for that reason I'm ruling out this method as being a viable option. Way too much hassle. The second approach you could do is create a utility method that you can invoke through a Spring spell expression directly in the template that will let you modify the query string directly. So an example of that is creating a class like this, QSUtil, annotate it with component to make it a Spring Bean. We could name it QSUtil, which is what we'll refer to it in the template. So if you wanted to create a method that uppercases a string, it's just as simple as defining it here, and you can call it through a Spring spell expression. Just to give you a taste of how that's done. th text, to invoke a spell expression, use the @ symbol. We should get autocomplete here. And yeah, it's as simple as that. So you could imagine this could be useful to create a method called increment page, and I'll just show you that it works. So you you could create a method here called increment page that accepts the current query string. Then you have to split the query string through the ampersand to extract all the key value pairs, and you'd have to sort of loop over every token. Is the token the page key? Cast to in. If it's valid, then increment. And then you'd have to rebuild the entire query string again, so you don't lose all this other information. And then if you wanted to maintain the ordering, you got to keep track of the ordering. So yeah, it gets complicated pretty quick. So for this reason, this isn't a valid approach because it's very error-prone code. The module that I've created is heavily tested, so it just makes your life a lot more easier. So I'm going to remove that, and now I'll get into explaining how to use the query string manipulation module. So we'll just work on the next button to start with. So what we need to do is we'll start by creating a variable called new query string, and we need to access the query string module. We can do this by prefixing with QS, and you'll get all the autocomplete options here, which are available on my GitHub page for the documentation link as well. We need the increment page method. There's two methods available. You can read the documentation here, which also covers example usage and the different scenarios that you could encounter. So this method here, it will just continuously increment the page regardless of whether or not you're on the last page. So it's just here for the sake of providing another option in case you don't want, because you could implement the validation logic in the template itself. Otherwise, we're going to use this method here, which you can supply a max bound, which will be the last page. So basically, if you're on the last page, it's not going to increment any further, so we don't have to provide additional checks in the template code, which makes the template read a lot cleaner. So this method accepts a query string and a max bound, so let's provide the query string. You can get this through the request object. And then we need the max bound, which is just the last page. So I've defined some useful variables up here, just because I think it reads a lot cleaner. So the last page is just the number of pages minus 1, because this is based on 0 indexing. So the results variable, just to remind you, is of type page. And in here it has the get pages method. You can also access the pageable, which has different options to get paging details. So that's what I'm using to extract some of the information here that I need to perform some additional logic. So yeah, that's it. This method will go into this query string, only update page to be the next value of 1, only on the case that we're not on the last page. So I'll show you that in action once we've set it up. The next thing to do is we've modified the query string, but now we need to rebuild the URL so we can navigate to the correct link again. So we need to take the current request URI and concatenate it with a new query string. So I've created a convenience method for that. So we create our href. So we access there's a URI method, the URL method here. I'll show you how the URL builder works later. But for example, we can provide the request URI. And then the next parameter is the query string, which is the new one we just created. And yeah, that's all there is to it. So Let's restart the application, then we'll see if it works. So if we go back to our home page here, there's no paging explicitly in the query string, so what will happen is it gets treated as an implicit page equals 1, or page equals 0 being present, so it's equivalent to having that in there. So when we click next, it will, if it's missing, it will explicitly add it to be the next page, and we can scroll through to the last page. Since we're on the last page, it won't let us go any further. That built-in, that's what the max bound checking does. If you use the other method, it will keep going. So yeah, it's better just to use the max bound one. So yeah, let's now implement all the other buttons. So because we're on the last page, this button here should go back to page 0. Otherwise this will go back to page 1, and likewise this will go back to the very end, or we'll go forward to the very last page. So let's go to this one. This one here is the double left arrow, which will go back to page 0. So to do this, it's pretty much just following the same sort of pattern. QS. So I've got another method here called reset page number. Sets the page key to 0 should it exist, otherwise explicitly adds page equals 0 to the query string. So that's exactly what we want. Get query string. So if you didn't want to type query string out all the time, you could just define it up here. Just clean up some of this formatting here. So you could do that if you wanted to clean this up a bit, which, yeah, I might do that now. So this will reset the page to 0, and from here we just need to rebuild our href. So it's pretty much, it is exactly like this. So I'm just going to copy and paste that there. So like I was saying before, you could improve the readability of this a little bit by providing a URL builder. Remember to move that. So what we can do here is it's basically a carried function. So you can provide the initial URL, URI. So that means you don't have to provide it every time. So instead of this, so that basically just sort of improves the readability a bit. We can replace that down here with that. And yeah, that will reset the page back to 0. Just going to copy and paste this one here. So this one here will go back, we'll decrement the paste. So we want to use the decrement page, and then rebuild the URL. The last one here, we want to explicitly set the page to the last page. We have a set page number here. So we provide a query string. It sets the page to the supplied number should it exist, otherwise explicitly adds page number to the end of the query string. So we've got a last page here defined up here, which is just total pages -1 due to being a 0 index. And then we can rebuild the link again, and that's all done. So give that a run. Go back to our homepage. So this is there's no paging here, but if there's no page, it just adds one. So we can go back. So if you're on page 0, you can go right to the end, and then if you're right to the end, you can go back to the start. So as an example, using it with multiple key value pairs, you can just notice that it only replaces the page while keeping the original query string state. Likewise, you can go back to the start, go back to 0. You can't go below 0 due to the checking that's already been done. And likewise, you can't go past page 1 either, because that's the last page. You can also perform some conditional logic to make these buttons only appear, but that's just something you can do to make the UI a bit nicer. So I'm just going to do that to finish it off. So with the back to 0, I only want to show the back to 0 button basically if there's a previous page. If there's no previous page, there's no point showing back to 0. Same with the decrement page, there's no point showing that if we're not on, if there's no previous page to go to. We only want to show the next option if it's possible to go to the next, if you're not on the last page. So providing we're not on the last page, we'll show both of these options. So you can see those buttons disappear now because, if you can't go back, there's no point showing them. So yeah, that pretty much does it for paging. There's a few other features I'll go back to later in a few videos time, but hopefully that helps. And in the next video, we'll have a look at how we can sort these columns. But yeah, thanks for watching, and I'll catch you in the next video.